Okay, so we are going to be doing moderated mediation today. We're just going to do this model. I prefer not to call it Model 7, but I'm going to have to call it Model 7, which means when we open process, eventually we will have to call this Model 7. The point that I want to make is we have this conceptual diagram, right? And if you were doing a path analysis, this is exactly how you would specify this out. In process, it breaks this down into multiple different regression models, right? It breaks it down into a regression model in which all of these variables are predicting this, right? That's regression model number technically 2 or 3, not 1, right? You have regression model 1 where X is just predicting Y, and then we have the final regression model where all of these are predicting Y. They're all in there, right? And so when we're doing something like this, like let's pretend that W is not here right now. If we run this in process, we have X predicting M predicting Y, and then X predicting Y, and this path right here is called what? C, or also known as the direct effect, right? And this path that goes through here is known as what? Indirect effect. And we get that indirect effect by doing what? Multiplying this by this, right? That's all it is a multiplication of these two slopes. All right, now let's pretend like Y is not there and it's just X predicting M with W predicting this slope. And I think it's, the prediction of this slope is really saying that there's a relationship between X and M, right? And that this relationship can be predicted by W. In other words, there's a significant effect of W on this path. That's what an interaction is, right? It is really the significant effect of W on an X to Y path, or an X to M path in this case. So putting these two things together, we say that there's a significant indirect effect between X and Y via M, and that significant indirect effect varies because W changes one of these slopes, right? At mean levels of W, when W is centered, that is what our main effect, our mean relationship between X and M is going to be, correct? And if we know that we have, if this coefficient down here, X times W, is statistically significant, then that means that this path, which we call A, right, has different values based on whatever W is, correct? And in the past, we've calculated this out by doing what? So yeah, regression. And in the context of regression, we have done this kind of thing where we have a path like this, right? And this is X. I mean, technically this is X and this is Y, but this is the path of X at mean levels, right? And then we say like, well, what about when W is at plus 1 SD? Oh, well then the path is this, and that is X at plus 1 SD. Oh, I'm sorry, when W is at plus 1 SD. And this is X when W is at minus 1 SD, right? And so if we have this path model like this, X predicting Y with M here, and so we have B, A, C, and W. So that's just the exact same model that we're looking at up there, just flipped, so I'm not reaching too high. What is A over here? xm, right? So we have xm, and then our indirect effect is A times B, right? And our total effect is what? It's going to be A times B plus C, right? And that's when everything is this, when everything's held constant at its mean. However, in this particular case, these values all vary as a function of W because this path varies as a function of W. So we also have at plus 1 SD. What is our indirect effect at plus 1 SD? Our equation over here would be what? I mean, in this instance, we're saying A equals xm, so maybe we call this A sub 1 and say that A sub 1 equals x when W is at plus 1 SD, and A sub 2 is x when W is at minus 1 SD, right? And we'll call this one A sub m. So this is A sub 1 times B. And then our total effect is going to be A sub 1 times B. B doesn't ever change, right? Like this slope, there's nothing moderating this slope. It's never going to change. Plus C, same, never going to change, right? And so now we have an indirect effect that is the indirect effect and the total effect when W is high. And similarly, we can do the exact same thing when W is low. We have an indirect effect. What does it equal when W is low? A2, B, and the total then is A2, B plus C, right? And so in this case, there are 3 indirect effects, right? And 3 total effects. So if this value is 2, and this value is 3, and this value is 1, then this value is what? Xm. It's 2. Let's just call this 2, and let's just call this 3. What is our indirect effect? Our average indirect effect. Or our indirect effect when W is held constant at its mean. And its mean is 0, right? What is our indirect effect here? No? 4. That's 4. 2 times 2, right? It's 4. What is our total effect? 7. What is our indirect effect at high levels of W? Somebody say it. 6. And what is our total effect when W is high? 9. And similarly, what is our indirect effect when W is low? How'd you get 2? And what is our total effect when W is low? 5. So we have indirect effects on average. Here's the average indirect effect, right? The indirect effect when this is high, when W is high, and the indirect effect when W is low. Notice that B never changes, right? You're always multiplying times the same over here. And you're always adding the same here. The only thing that varies is that you have x sub 1 equal to 3 and x sub 2 equal to 1. And so these values wind up changing as a function of W, right? And consequently, the indirect effect winds up changing as a function of W. And in this case, the strongest indirect effect is where? It's right here, right? So when we're at 1 standard deviation, our indirect effect is 9. And I mean, we're using these kind of weird numbers because very seldom do we see the numbers like this high, right? But you can also conclude something else, because when we do these indirect effects, you have both standardized and unstandardized. If you have a standardized indirect effect, then you can actually say, like, at high levels of W, right, our R squared for Y is blah, whatever it is, right? It's going to change. It's going to be stronger. It's going to be higher in this case, which means for these people, we can explain more of the variance in Y. And for these other people, we can't explain as much variance in Y, or the relationship between these two is less robust, right? Does that make sense to everybody so far? So when you have something like this, you wind up having to recalculate your indirect effects as a function of, right? I'm going to show you guys actually a cool figure that we're working on for a paper in just a second here. But you wind up having 2 figures, right, for something like this. And this is an important question. Like, how do you wind up mapping this out? I mean, you can get creative with these things. We'll come back to this in a second. The most common way that you see is the way that's right up there. X predicting Y with M, and then W predicting this. And then if you were to put this into a paper, right, you would wind up having actually a path that gets specified there as well, because you have to have your main effect, and then this is technically your interaction, right? And you have this, you have this, you have this, you have this. You could draw all those out, right, in a figure, like if you're making a figure to put into a paper. But we're missing something here that we've done every single time that we've done interaction effects. What are we missing? What's that? Yeah, we're missing the visual of it, right? You'll have the numbers there. So you can do figure 1, and then you could do figure 2, which is this. And you just have x, y, right? Plus 1, minus 1, 0. So you could say, like, hey, we did this. Here's the model we specified. Here's what the interaction looks like, right? So be creative. What's another way that we could do this? Is there a way to put this all in a single figure? You could do something like this. could do x, y, m, I'm going to leave this open for right now. And you could put something in here that says W m, W minus 1, W1. And you can put what your value of this slope is. We did 1, 2, and 3 based on high, low, and medium. And then you don't even have to draw any of that out, right? You're saying like we tested this and this is what, this slope is different based on these various levels, and here's your slopes, right? You can just list those right in there. That's one way to do it. Another way, I will pull up something here real quick. So this is actually an honors students project that we're working on. If you guys, I say this all the time, and I will say it again today. I love to make, I love to make creative figures. And so I'm going to show you guys a creative figure that I'm doing with this student. This is an interaction effect where we did the interaction here is by, these are two different groups, head people versus heart people. Very weird area. Like this is combining social psychology and clinical psychology a little bit. So there's this this is again a weird aside, but there's this social psychologist who asks people like, are you a head person or are you a heart person? Irrespective of what you know about biology, are you a head person or a heart person? And it actually is like very predictive of a lot of different things. And so, and in this case, we find that it moderates the relationship between protective strategies and alcohol consumption. But anyway, so we put like this call out, right? So I listed these, but also threw this in there to make a single figure that has both the different slopes as well as the interaction effect depicted. The point of this is just like, get creative with it, right? Like you can do some really cool stuff, and it's more important. I think it's important to be able to, when you start getting creative, I think it makes you think about your data a little bit more. It makes you think about what you're doing with things. So for your final, think about that. Like, how could I make this creative? And please don't give me like these terrible printouts from, I mean, give me your printouts from Process, like paste those in, right? Actually, Process, so Process doesn't give you figures, so we don't have to worry about that. Actually, I'm going to show you how to get figures from Process today, but for the most part, Process doesn't give you figures. Okay, anyway, let's have a look at these models in Process. So you guys should have your data downloaded. And this is the data for today. And the model that we're doing is model 7. So, does everybody have SPSS ready to roll? Let's not worry about installing. Have you guys already gone through and done the processes of installing Process and the Process macro? Okay, so we're not going to use Process just yet. Let's just do a straight regression analysis, okay? We have BIS and BAS. This is behavioral inhibition and behavioral activation. We have affect lability, ALS. And then we have, these are our outcome variables. General distress mixed, general distress anxious, general distress depression. So let's start by, actually, so we already have centered BIS and BAS, so we need to go transform. Actually, let's draw it out. This is the model that we want to test. We are going to look at BIS predicting ALS, predicting GD mixed, and VAS predicting that. Given what our data looks like right now, what do we need to do in order to make this, run this type of model without using process? So if we look at our data sets here, I've already centered some of this stuff for you. If we didn't have access to process, what's the first thing that we want to do here? Okay, so what's the first thing that you said? Okay, so how do we do that? Okay, transform, compute. You're absolutely right. So we're going to go BIS x BAS, and then we're going to say mean-centered BAS. Oops, it's not mean-centered. BIS times, is it this one? Yep, there we go. BIS times BAS. And it's in there. It's multiplied. All right. Now, what is the next thing that we want to do?
Well, if you're using ALS to predict, wouldn't you want to center ALS as well?
No, you don't need to. What else do we want to do here? In fact, in this case, I would say do not center ALS because it's also serving as an outcome variable in the fact that it's a mediator, right? If, however, just to throw this out there, if, however, we did this, which we're not going to do, but if we did do this, and let's say we didn't do this, I would absolutely center ALS, right? And then, well, we're not going to worry about it, but this is another process model, right? And so if you were going to do something like that, obviously draw it out first and find which process model, but you don't even really, you only need a process model because process forces you to put a model number in there. In a straight regression analysis, you should be able to do this yourself. All right, but let's get rid of this one. Ooh. Okay. What's the first thing that we need to do? We're going to test this just in regression. What are we going to do? What's that? Sure, you can use the Barron and Kenny method with this. You wind up having to throw in a few extra steps because the Barron and Kenny method doesn't have a moderation model in it, right? And you'll wind up having to run that Barron and Kenny method 3 times rather than just 1 time, which is fine. It's okay because we're trying to get those high and low slopes. All right, so what do I do? Somebody tell me what to do here. What's the first thing that we want to test in the Barron and Kenny method here?
We want to check the first model, like EMS predicting and the reduction predicting ALS.
Perfect. What do we do? What do I put in there?
ALS as DV.
Okay, there we go. Analyze, regression, linear. You can see that I haven't installed process yet on mine. ALS as the DV. Which one of these is ALS? Is it this one? Nope. Is it this one? Where the heck does ALS fall in here? Oh, it's right after the centered BIS-BAS, so it must be right here. Okay. And then what else? This is an independent variable. This is an independent variable. And this as an independent variable, right? And so we're testing a portion of that model. We hit go. And we see that we do have a significant interaction effect, right? So we have tested now this portion of the model, right? What should we do next?
What does the final square say?
Over here?
No, the next
This? I don't know what you mean.
one. The last
Oh,
one.
this GD mixed? Yeah, that's what we would do next, right? So now we want to go and look at GD mixed. What are we going to do there? Do we include our interaction effect in this final model? You can, but you do not have to, right? Because the point is we're breaking this up, and this should only matter over here, right? However, in regression, if we don't include it in there, like in a path analysis, this is nice and easy, right? But if we don't include it in there, then alls predicting GD mixed, this is what it would be, right? BIS predicting GD mixed. But the problem, and then the covariance between those two. But the problem is we're missing covariances between BAS and BIS by BAS with alls and with BIS. And so we wind up having this weird situation, right? We're gonna flip over now. Actually, we're gonna run this two different ways. Let's start with that, and then we will flip over. So the first way would be to include everything in the model, right? And what that means, though, is we are going to have to add these paths, which are not in our traditional model, right? But let's add them. Let's go analyze, regression, linear, and we're going to take that out. We're going to plop it in here, and then we are going to put in GD mixed up there. And the only thing that we're really interested in this model is what? Ugh, hold on a second. I gotta switch these names. It's gonna drive me crazy. We're gonna run that thing again. Okay. The only thing that we're really interested in this analysis is what?
Would it just be the ALS?
ALS, yep. That's all we're really interested in. Now, of course, this analysis is not quite right because we have these pieces of this model that are removing variability, and in some cases, significant variability from our outcome variable, right? In some cases, non-significant variability from our outcome variable, but still variability that could be accounted for by something else. The other option, analyze, regression, linear, is to pluck this out and pluck this out. And in this case, they're not much different, but you can see they are different, right? Our r squared 0.617 versus an r squared up here of 0.623. So what is the right way to do it? Let's see what process says. So what's the first thing to do in order to install process? What do I need to do? Say that again. Extensions. Then what?
Install custom dialog.
I think we need to do something else first. What's that? There we go. So the first thing I need to do is go open, syntax, users, downloads. Wait, are you saying I don't need to run the syntax to do this?
So like if it's already there in the utilities, then you can just run directly from
Yeah, that's what I did. I just went straight. Yeah, I didn't do this.
Oh, really? And it works?
get
See, I don't know. I just hate process so much. Okay, so that means that I don't actually need to do this, but I'm going to do it anyway. I'm going to run it. There we go. That's interesting. I've always been taught that I had to do it this way, through these specific steps. That's not quite the deal, huh? Okay, so extensions, custom dialog builder. This is, oh, nope, whoop, sorry. Extensions, utilities, install custom dialog. And custom dialog builder file. So this is what you were saying is all I would really have to do, correct?
That's what I did.
Okay. Let's let this spin for just a moment. And it should give me a message dialog box, right, that says like, hey, it's been added now.
it's already done before.
You think it'll work right now? No, I can't click on it. I mean, I can click on it, but nothing happens. I think it's still installing. Because shouldn't I get a little pop-up dialog box? I'm pretty sure I get a little pop-up dialog box that will say like custom dialogs installed under regression linear or something. Yeah, right there. Installed 2. All right, so now we can go analyze, regression, and there it is. All right, so what are we going to do here? What's that? GD mixed, okay. So we're going to put GD mixed as the Y variable. What's our X variable? BIS centered, right? What's our M variable? ALS. Where do we put BAS in the interaction with BAS?
Go back.
Okay.
Interaction goes as a moderator.
What's that?
Doesn't the BAS go as a moderator?
Let's start with this. Oh yeah, you're right. We're going to start with this. What model? So this is why I dislike process. If you try to build anything yourself, you don't have the right model for process to work, right? So this right now does not match model 7. And I don't think process will let you run this as model 7. Let's see. It is technically, mathematically model 7. We hit go. Let's see what process tells us. It's thinking. I don't know if this will work or not. I don't think it'll work, to be honest. Error. You have specified W variable model. It requires W. Mathematically, it should work, but process is finicky. So let's go analyze regression, linear. Whoops, not analyze regression, linear. Analyze regression process. Pluck these out. And instead, what should we do?
Yes. Center BAS is W.
Okay.
Get the action covariate.
Wouldn't it make the interaction for you?
Process will make your interaction for you. All we have to do is this right here. Let's hit run and let's see what happens. All right, we have something. There is BIS, BAS, and this is your interaction. It makes it for you, and it just calls it int1. Is our int1 significant? Yes, it is, 0.0017. If we scroll up, well, let's not do that just yet. Then it gives us our conditional effects at various levels. And the levels of BAS are minus 0.8415, minus 0.0315, and 0.8245. Here is our model with BIS and BAS, and it does not account for the other pieces of it, but it will account for them down here, and it will give you your indirect effects at high and low levels of BAS. There's a problem here because it lists our BAS at minus 0.0315. Let's do this. I'm going to show you guys something that does actually make process kind of nice. Let's go process, and let's remove centered BIS, and let's remove centered BAS. Because sometimes we run into issues with centering where we think we've centered a variable, but it's not really centered because we're missing data on outcome variables, or we're missing data on our interaction or our W variable, which SPSS will delete listwise, right? And all of a sudden our variable is not truly centered anymore. So let's put BIS non-centered right here. And let's put BAS non-centered right here. And now let's go to options. And right here, mean center for construction of products. And you can also choose the conditional values. And we're going to look at minus 1 SD, mean, and plus 1 SD. You can, if you select Johnson-Neiman output, it will give you all of these values and show you at what point we cross that threshold. Johnson-Neiman is our regions of significance, right? All of a sudden, process is doing some pretty amazing stuff for us. It can do one other thing. Well, I mean, it can do multiple other things, but click this, generate code for visualizing interaction. Hit OK, hit OK. All right. Model 7, here's our outcome variable. Interaction 1, 0.0298. Tests of highest order unconditional interactions. This is statistically significant, and this test of a higher order R squared. Remember I said that in straight linear regression, the addition of an interaction is the exact same as a test of our change in R squared, 0.017, 0.017. Those two things are exactly the same, like they should be. The important thing is now we see that when we allow process to center our variables, it will give us an actual centered BAS. What was our BAS value in the middle before? It's like minus 0.03, right? Which means our centering was off just a little bit. This is one of the nice things about process is it will tell you if your centering is off. Here's -1 standard deviation. Here's +1 standard deviation. This is the effect of X at -1 standard deviation and at +1 standard deviation. This is the effect of X. X is what? And what? Yep, and what is, it's BIS, right? Right here, it is the effect at mean W is 0.0322. That should match this, and it does. Whoops, that's from our regular model. 0.0322, it does match that, so we know that we're good to go there. The moderator values defining Johnson-Niemann significance regions are listed right here, and you can actually like scroll all the way down and bam, right there you see that when BAS is at a value of 0.4648, that is when we see a significant effect occur of BIS on alls, right? And any value of BAS less than that, less than minus 0.4648, BIS no longer predicts alls. We are going to do something here in just a second to get a better visual of that, but this shows at what level. What was our 1 standard deviation of BAS again? What value of BAS was 1 standard deviation? It was no. The 1 standard deviation above and below 0.8. Yeah. 0.8 minus 0.8 of BAS, right? That's 1 standard deviation. So if we look down here, this is like roughly a minus 1 standard deviation. You can see it's not statistically significant. This is at 0.4648. So this isn't, remember, it would be nice if we could say like, oh, well, that's a half a standard deviation, but that's not quite right, right? Because standard deviations, distributions aren't flat. It's curved, but it is roughly half a standard deviation. But at roughly half a standard deviation, below on BAS, when BAS is low, then pretty soon BIS is no longer predicting affect lability. All right, if we keep scrolling down, we get this data for visualization. We're going to come back to that in just a second. Here are our regression models. So here is our BIS and alls. And of course, this is not accounting for, again, that covariance in the interaction or anything. So it is only giving us this portion of the model, right? The portion of the model that we're specifying here, and it's excluding the interaction and so on. This is one of the problems with process versus doing a straight path analysis, is you're not actually able to control for the covariance piece of it because it's a regression model, not a path model, right? Okay, but our indirect effect of X on Y is 0.2841, and that is when W is held constant at what? 0. Yeah, it's mean, right? We also have these conditional indirect effects. And here are our conditional indirect effects. When W is high, it is 0.5344, which is dramatically more than this. When W is low, it's 0.0792. And when W is held constant at its mean here, it calculates this out based on the removing that covariance. So it winds up being not quite the same as what you get up here, right? Because it does wind up including BAS in this model of GD mixed. Okay, let's do something now. I want you to scroll back up to this right here. Double click in your output.
I had a question.
Yeah.
There is something called index of moderated mediation, which was coming in the process results. Index of moderated mediation.
Index of moderated mediation.
Yeah, that's coming there.
It's down here.
Yeah, this one. So, like I don't know how important is that this index should not contain a zero confidence interval.
So the index of moderated mediation is the same as the direct effect of x on y, right? Gosh, I'm trying to remember exactly what the deal was with the effect is the same. Oh, this is using bootstrapped standard errors. Ah, that's right. This is actually the index of the indirect effect that you want to report, right? Because this one is the one that's using bootstrap standard errors. The one above is not using bootstrap standard errors. Does that make sense? And so in this case here, it is correcting for the fact that your distribution of product coefficients is not normally distributed. So that's all it is. So your effect will be exactly the same because it's still multiplying A times B, but your standard errors will be different because they're bootstrapped. Okay, let's scroll back up. And so let's double click in your data and highlight this. And hit Command C or Control C, whatever, probably Control C for you guys. And now, let's go File, New, Syntax, and Control V. I don't know if I have to highlight this or not, but I'm going to highlight it. We had asked Process to do something for us. Specifically, we had asked it to give us data to generate a figure. And there it is. There is our plus and minus 1 standard deviations. It's beautiful, right? Unfortunately, it's hard to understand what's going on here. So let's double click on our figure. And it should open up our figure properties. And let's add, not fit lines, interpolation lines. Close, close. And I still think it's ugly, but there is our plus and minus 1 standard deviation figure. Now, if you're going to do this, you're not going to use SPSS, right? You guys are going to make these yourselves in Excel, but you can use SPSS to make sure that what you're making looks like what SPSS is making, right? You can double check what you're doing. This is, in my opinion, not a publication quality figure. It's super ugly, but at least you can double check your data against theirs. And that is it. We've got conditional indirect effects. We've got our figure. And that is how you do moderated mediation within process. What questions do we have right now?
Can we go over like a mock write-up and what
Oh yeah,
would like
that's a good question.
we would have to report within Texas?
So here's what I would do if I was going to write this up. I would say we specified a moderated mediation model. See figure 1. Don't say process model number 7. Although people will put that in there. It drives me crazy. But I would say see figure 1. In this model, GD mixed was regressed onto the mediator, affect lability, and the criterion variable, behavioral inhibition, right? BIS. The relationship between affect lability and BIS was moderated by BAS. We examined the indirect and total effects of BIS on GD mixed via affect lability at high and low levels of BAS. You might throw in there like there was a significant effect of BAS on the relationship between BIS and affect lability. Or you could say BAS moderated the relationship between BIS and affect lability, right? You can describe that in any number of ways. And then I would say there was a significant indirect effect between BIS and general distress mixed via affect lability. And then I would list it. List your indirect effect and list your 95% confidence intervals for your indirect effect. Then I would say, given that the association between BIS and affect lability was moderated by BAS, we examined conditional indirect effects of BIS on GD mixed at high and low levels of BAS. You don't have to type all this out because I'm recording it and I will put it on YouTube, but I see you typing furiously over there, Sarah. And then say at high levels of BAS, the magnitude of the indirect effect between BIS and GD mixed was potentiated. I like to use that word, right? In contrast, at low levels of BAS, the magnitude of indirect effect was attenuated and no longer statistically significant. Is that true? Was it no longer statistically significant? Yeah, that is true, right? All right, that's how I would write it up. Any other questions? Somebody's calling in with one? All right. So I guess that wraps up moderated mediation.
Oh, yes, sorry. With regards to graphing this in Excel,
Yeah,
can we go over that?
sure. I mean, it's exactly the same as what it would be in a regular
So we would
moderation
just point to,
analysis.
like, where in process,
Where in process
like
would
the
you do
output,
this?
sorry, in terms of,
Sure. This is it. It's the very first model.
okay,
And you would use these coefficients right here, right? This constant, BIS, BAS, and interaction. The nice thing is you don't have to center and reform and do all of that stuff. Process does it for you. And in fact, you've got, we can graph this real quick. Let's just pull up one of our graphs that we use. I'm gonna scroll up here to ARM2. I don't remember which week we were doing this in. Let's check week 9. No. Week 6. Where did I give you guys the graph for this week 5.
The two-way,
Yeah,
week 7.
and I don't even have week 7 listed in here. Wonderful. Let's go into arm 3 and see if I can find that two-way graph in here. It's not there. Or there. Come on. Linear two-way. Here we go. Okay. What is our plus and minus 1 standard deviation of z? What did SPSS use as it? What did process tell us was, I said z, w, I'm sorry. What is plus and minus 1 standard deviation for BAS? 0.8. So let's go 0.8 and let's go minus 0.8. What is our effect of x? What is BIS in that very first model? In process, it is 0.0322, right? 0.0322. What is BAS? 0.0455. What is our interaction? 0.298. And what is our intercept? Say that again. 1.92. Okay. That looks terrible. Why does it look terrible? Our range is really bad, right? What is the range of GD mixed? Actually, what is the range of X? Let's start with that. Somebody can find it for us if they just go, well, let's do this. Yes. Analyze, descriptives, explore, and BIS. Why is it, am I missing something here? There we go. Centered BIS, said okay. And it ranges from minus 0.3 to 0.3, roughly. Whoops. We have it ranging from 10 to 10. That's obviously not good. Minus 0.3. Let's go plus 0.1. And drag that down. Still looks terrible. What's missing now?
The range of y.
Yeah, the range of y. And let's leave it at 1, and let's just call this 3, maybe. It still looks terrible. I don't know what our range of y actually is, but it must be pretty slim.
Can I just ask a question just to double check that I'm not misunderstanding something? When you did the range, you used the confidence interval, lower and upper bound?
Oh, did I grab the wrong thing? I did get the wrong thing. I'm sorry. It should be this. Minimum is minus 11, maximum is 7. Is that right? Yeah. So minus 11 to 7 or 8. So minus 11. And let's keep that as 1. There we go. Thank you. What is the range of our dependent variable then? I mean, we could stick with this range. That's not too bad, right? And this is roughly what SPSS looked like as well, correct? Not exactly, but this should be a non-significant slope, significant slope, significant slope. And so you can check it against it. And in fact, if we go back to SPSS and we set our values to match the range of the values in here, -4 to 4 and 1.7 to 2.2, we can do that, right? So -4 to, let's just grab this, pull it up to 4, 4, 4, and this was, what was it? 1.7 to 2.2. And it should look nearly identical to what we get in SPSS. Looks pretty close. Good to go? Any other questions, comments, concerns, thoughts? No? Okay. So that is everything. That's everything that I have for you guys for the rest of the semester. This is the first time that I've taught this class, and I've had a lot of fun teaching it. I appreciate you guys having patience with me as I slowly work my way through getting through your homework sometimes. I hope that it was a good class for you guys. It was a great class for me, so I don't care what you guys think. No, I'm just kidding. I mean, I really hope, like, the main point is that I want to know who feels confident that they could get a data set and run a regression model now, and test for interactions and test for mediation and not use process, but use process if you need to, and be able to describe and explain what they are doing. You guys feel confident? Who does not feel confident that they could do that? Okay, fair enough. That's the goal, right? Of course, if you don't feel confident that you could do that, there is no way you're going to raise your hand right now on the last day of class in the last few minutes and say, I don't know what I'm doing. But no, as I remember in a graduate regression class, or my first graduate regression class, at the end of the semester feeling like I didn't know what the hell I was doing. And I took it in the stats department as why. Like, those are tough places to take stats classes if you're not a statistician. So this is completely unrelated to mediation or moderation, but I heard this, there's just out of curiosity, who listens to podcasts in here? You business folks, any of you listen to Planet Money?
I started since you talked about it.
Oh, okay. So Planet Money replayed one this week called The Weight of the Cow, I think is what it is. Have you listened to it this week?
I started this morning.
So it's based on this great story. I'm going to stop the recording because we don't need the recording.